Hello everybody and welcome to yet another math video. In this video I'm going to cover how to solve compound inequalities and a very specific type of compound inequality. These are what we would call AND inequalities, and this happens when there are two or more inequalities in a specific statement. You can see an example one like this one and this one, all strung together in one statement, like this. Generally, the variables will be in between the two inequalities. There's another type of compound inequality called an OR compound inequality, and that will not be covered in this video. So just right now, the AND inequalities, you will solve darn near exactly the same way as a regular linear inequality. So for example, if this 7 less than did not exist, how would you solve this inequality? Well, you would want to make sure that the variables are on the left. That's fine, it's already there. But then, I guess the only other thing here would be to subtract 5. Now, I mentioned the variables start in the middle, and the variable at the end should stay in the middle. So we're not going to move a variable around, but because I subtracted 5 from the middle and the right side, I also have to subtract 5 from the left. And that's how it's different. So we will have 2 is less than 3x is less than 6. And if you wanted to solve this particular inequality, isolate the x, you would divide by 3. So go ahead and divide by 3, divide by 3. That cancels the 3. That leaves you with a 2/3 is less than x is less than 2. That's it. We've solved the compound inequality. There it is. That is the inequality notation. The set builder notation is exactly the same as the inequality notation with a little bit of extra window dressing. So less than x, less than 2. You will take your inequality. It becomes part of your set builder notation. You'll put a vertical line to the left of the inequality, and then whatever variable you use to the left of that, and put some curly braces around the entire thing. And what this tells you is x is our answer as long as, that's what this vertical bar stands for, as long as x is between these two numbers. There we go. From here, you can graph this inequality on a number line, but instead of having a single important number like you would on a linear inequality with only one inequality symbol, we have two numbers that we need to put down here. So just make sure they're in the correct order, and they are in the correct order up here. 2 is less than, 2/3 is less than 2. So we just keep that order preserved. So 2/3 and 2. And inequality of strictly less than both times means we will use open dots both times. And we will shade between these open dots because that's where the x is. It's saying x is any number between these two numbers, so we shade between. And that makes the interval notation much easier for compound and inequalities, because the starting value and the ending value are both going to be numbers. So this shading here between 2/3 and 2 starts as far left as 2/3 and goes as far right as 2. And because we have a strictly less than with the 2/3 and an open dot with the 2/3, then we will use a parenthesis with the 2/3, and something very similar happens for the 2. Okay, let's take a look at example 2. This is the last example for this short video. We do have a fraction I see right here. And what that means is I need to take each term and multiply by 2. So the next step here will have everything listed out, everything multiplied by 2. And what that did is it got rid of the LCD. So LCD here was 2, multiplied everything by 2, this is what you get. From here, you can see that we can pretty easily solve for x by subtracting 8, which gives 4 is greater than or equal to negative x, which is greater than negative 2. But this is not just x isolated. So the last thing we need to do is divide by -1 or multiply by -1, whatever makes you feel good. And that gives you a -4, an x in the middle, and a 2. But what happens here as well is the division by a negative, even though this is a compound inequality, will change the direction of the inequality symbols, just like regular linear inequalities. And that's basically it. This is the inequality answer. We can rewrite this if you want to, but I don't think there's a reason to. And one thing I want to point out before I get into the rest of these answers here is that when you have an and inequality or a compound inequality, the inequality symbols should both be facing the same direction or read the same way. This is 7 is less than, this expression is less than 11. Yeah. Also, it's true that 7 is less than 11. So yes, this makes sense. 6 is greater than this, which is greater than 3. These were said the same way. Even if there's an equal to, they're both greater than. And you'll notice that after we divided by -1, they are both now less than. So they are still both facing the same way. All right, the last few answers here are going to be x as long as x is between these values. The graph looks something like this, from -4 with a closed dot this time, all the way over to +2 with an open dot, and it is shaded there, which means we have a starting value of -4. That's how negative this starts, or how left this shaded area starts. And it goes all the way over to 2. Lastly, this will show up occasionally, even if it's just numbers. There is a square bracket around the -4, and that's because the equal to originally here in our inequality notation, it followed it here, it's closed dot here, square bracket. While the 2 has a parenthesis around it. And you can see that here. The strictly less than symbol that ends up with the 2 leads to a less than, leads to an open dot, leads to a parenthesis. That's it for this video. Thanks for watching.